Welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences ITB. So we are still going to discuss Introduction to Integral with special topic focus in area between two curves. Let's start. Okay, so we want to calculate the area between two curves as follows. Okay, so I have curve y equals fx, I have curve y equals gx. I want to find this area between interval a and b that is given by the region R here. Okay, this one, yeah. If I want to find the area under the curve y equals fx and above the x-axis, I know the integral is given by integral ab fx dx. Okay, yeah. What about the area here? The area below the y equals gx and above the x-axis, it is given by y integral f gx from a to b. What about this one? How do I find this? Yeah, similar. I can use this. This is the integral fx from a to b, integral fx dx. Okay, the area between curve. This is given by R1, area R1. And what about this one? R2. R2 is given by integral gx from a to b. Integral gx from a to b. So if we subtract this, we have this one, R. So R should be R1 minus R2. So I calculate this? Just the integral of fx minus gx dx. And this is just a generalization of the area under a curve from before. Why? Don't forget, if we want to find the area under curve y equals fx and above x-axis, from interval a and b, you have integral fx dx from a to b. What is integral fx dx from a to b? It's just integral fx minus 0. So gx should be 0. What is gx equals 0? Gx equals 0 is this one, x-axis, isn't it? So this is just a generalization from what we have learned before. Okay, before fx minus 0, and now in the generalization, it is fx minus gx. Okay, but it makes sense. The height times the width. This is the height times the width. Okay, yeah? Okay, let's try on one example. We want to find the area between this curve, y equals x squared plus x plus 4, and y equals gx equal x plus 8. I can know the graph is as follows. This is x squared plus x plus 4. Okay, yeah? And this is x plus 8. Y equals x plus 8. Okay, so in order to find the area between two curves, I take this one. So I want to find this area. How do I find this area? It is given by integral of the green minus red, that is gx minus fx, from this into this. So how do I know the left end and the right end of the interval? I have to know what is the intersection point. So how can we know the intersection point? Yeah, okay. We look at the y should be the same. So I have this equals this. I can simplify this. I can factorize into this. Okay. So the intersection point is x equals minus 2 and 2. So the graph, the area between the curve is given by this integral gx minus fx dx from minus 2 into 2. Okay, I have this. Don't forget it is minus all of this. Okay, I can simplify this into this. Okay, and I can use properties of integral. So I have this one. Okay, and I can use the formula for definite integral, that is minus 1/3 x cubed from minus 2 to 2, that is 2 cubed minus minus 2 cubed, plus 4 times 2 minus minus 2, because the antiderivative of 1 is just x. And I can just substitute 2 and minus 2, and I have this. I can simplify further into this, 32/3. Okay, so that's all how to calculate the area between two curves. So if I have area between two curves, I have to know which one the intersection point. So I have the left end and the right end points for the boundary of integral, for the integral, yeah. And don't forget, the area is given by the height times the width. The height is given by gx minus fx. Yeah, depends on which one is upper and which one is lower. So this is just upper minus lower times the width. The height is upper minus lower times the width. Okay, yeah? And I can just calculate this integral by using the previous lecture. Okay, the next one we will discuss about several examples, several applications on calculating area between two curves. Thank you.